And we are live, you guys. So it is Tuesday, April 28th. Oh my gosh, you guys. I know, we're all getting tired of this. Can't wait till life gets back to normal. And it will. Okay. First of all, let's talk about grades. So, incompletes. So, nobody gets an F, but you can get an incomplete. What is an incomplete? It goes I see in your report card. And you don't get credit until you make up the work. So one of two things. If you're a little bit behind, you can make up the work over the summer. That'd be kind of sucky, but you know, hey, that's the way it goes. Or if you're way behind, you haven't done anything, you have to make up the whole class, which is you have to take algebra again. Don't do that. That would be a bad, silly thing. So just keep plugging away and get your work done, and we'll give everybody complete grades. And then the nice thing is that everything's online. So all you gotta do is just watch the videos, okay? Homework. So last night's homework, let's take a look at that real quickly. So two names, you can do a set of CD, do DC or line M, plane A, call it plane A, B, E, okay. 3 collinear points, you can go A, C, B, and then third point E is not there. A point non-coplanar is point D, it's off the plane. Another name for PQ be QP, another name for RS be SR. All rays with endpoints TP, TS, TR, TQ, TP. Okay, those are all rays. Okay, so this was kind of hard to draw. Okay, here's plane M, plane N. You can see it three-dimensionally, and here's a line that goes right through it called K. 9. Here is AB, and I know that B is connected because they both have B, so I had to put B right there. And then finally, I've got a plane M and line K in. Okay, so anyway, that's how you draw those. So today, let's take a look at today's work. Today's work is kind of interesting, okay? So before we do a whole lot in today's work, I want to talk about this whole thing about congruent. All right, it's really crazy, okay, this word congruent. So we use the word congruent for shapes that are the same. So congruent, shapes that are the same. Okay, and then we use equal for their measures. Okay, so example. This line segment looks exactly the same shape as this line segment. So we would say that basically AB, we use this little equal sign with a squiggle on top. Okay, that means congruent to CD. Okay, they got the exact same shape. Example I give in classes, I would say, let's say Luke and I are about the same size. We wouldn't say we're equal. That would be a silly thing. We say Luke and I are similar or congruent, right? But our measures might be the same. Like Luke might be as tall as I am. So then the measures, so if I measure this, and I use my centimeters, it's about 1.7 centimeters. If I measure this, about 1.7 centimeters. So we'd say that their lengths are the same. But because their lengths are the same, we can say that AB is equal to CD because their lengths are the same, okay? So it's weird when we're talking about the shapes and comparing the shapes, we use this symbol congruent. We're talking about their actual, how long they are, their measures, we use the equal, okay? And you notice there's no line on the top, okay? We'll keep talking about it, okay? So, first of all, if I take a look at example 1, okay, and you can barely see my graph on here, are they congruent? Well, we've got to find out if their lengths are the same. So I'm going to just take my ruler and I'm going to graph this, okay? And let's see here, I'll go like this, XY, XY, there's my x-axis, my y-axis. So -5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. There's A, right? -2 and 5. There's B. Okay, there's my line segment AB. And what I can do real easily is I can count how long it is. 1, 2, 3. So the length of AB is 3. And then let's do CD. CD would be 2, -4, 1, 2, 3, 4. There's C. And -1, 1, 2, 3, 4. There's D. Sure enough, if I graph that in, I can just count how long they are, which is going to be 1, 2, 3. So here's what I say. I say two things. First of all, they have the same length. So I'm going to say, okay, AB is is equal to CD. So I'm saying their lengths are the same. They're both 3 and 3. And because they have the exact same shape, I'm going to say AB is congruent. See that little symbol? Congruent to CD, okay? Alright, it's kind of different, but we'll get used to it, okay? Number 2 and number 3 are very similar, okay? And if they don't have the same length, we'll say not congruent, okay? So, let's look at 4. 4 is pretty easy. To get VW, just subtract 31 minus 8. So all you gotta do, these are such an easy. I've got one good problem coming up in a second, but these are pretty easy. And I get an answer of 23, right? So VW is 23. Okay. 15, same way. 18 minus 6 is 12. Okay, that's pretty easy. And then in this case, you want VW. All right, just add them together. Get 75. 45 plus 30. Get 75. Okay, that's easy. Now, let's look at something a little bit more interesting. Turn the page. So I made a problem, and I want to take a look at this. I'm going to put this on graph paper. So, let's graph these points. A is 1, 3. Okay, I'm going to write that on my paper. So I have it. A is the point 1, 3. And B is the point 5, 0. C is the point -3, 2. And D is the point 0, -2. Okay, let's find out what's going on here. Again, I'm going to graph these. And these are going to be different. I'm hoping you remember something called Pythagorean's theorem. You should have learned this in 7th grade. Hope you learned it in 7th grade. So let's just go ahead and take a look at this particular problem. Okay, A is 1, 3. B is 5, 0, 1, 2, 3, 4, 5. There's B. I'm going to draw in my line segment. Oh, B. Seriously, Bill? B for Bill, huh? Okay, there you go. C, and I'll use a different color so we can see the difference in them. C is going to be the point -3, 2. And D is 0, -2. Okay, now if I look at these two, I'm not sure if they're congruent, okay? So what I need to do is find the lengths of them, okay? Now let's go back to Pythagorean's theorem real quick. Real easy little thing. Hopefully you learned this in 7th grade. Has to be a right triangle. Right, Pythagorean's theorem. Theorem is a fancy word. Theorem is just a fancy word for a math rule, okay? Just it's a fancy word for a math rule, okay? So if you got this side A, B, and C in Pythagorean's theorem, we learned that A squared plus B squared equals C squared, okay? Or, excuse me, the leg squared always equals the hypotenuse squared. This is the hypotenuse, it's always along the side, okay? So if I go back to this problem here, let's look at AB. First of all, I need a right triangle. Well, I'm just going to create a right triangle because I'm on graph paper. There's my right triangle right there. And that is a right triangle because we're on graph paper. So here's what I know. 1, 2, 3. 1, 2, 3, 4. And I want to know this side right here. So let's, on triangle AB, let's use Pythagorean's theorem. We'll call this C, which would be the length of AB. Okay. 3 squared plus 4 squared equals C squared, right? 3 squared plus 4 squared equals C squared, which is the length of AB. I've got 9, not 6, 9 plus 16, not 8, equals C squared. Okay, 3 squared, 4 squared. If I add those together, I get 25 equals C squared. Now to undo a square, we do the square root. Square root of 25. What times what makes 25? It's got to be a 5. Square root of 25 is 5. So I know that AB is equal to 5. Now, let's take a look at CD. Okay, the same thing, I need a right triangle. So let me see if I can make a right triangle here. Okay. And I'm going to go this side, which is 1, 2, 3, 4. This side is 1, 2, 3, and then that is C, or my hypotenuse. Okay, again, we're going to use Pythagoras' theorem. So we're going to go 4 squared plus 3 squared equals C squared, which is the length of CD. 4 squared is not 8, it's 16, plus 3 squared is 9 equals C squared. Okay, 16 plus 9 is 25 equals C squared. It's the same problem, isn't it? I like that. Okay, to solve for C squared, I square root both sides, square root both sides, and the square root of 25 is 5, and that's the value of C, which we know is really CD. So here's what I know. They have the same length, so here's what I'm going to state. I'm going to say that AB is equal to CD, because they have the same length. So no little bar, just equal sign, same length. But because they have the same length, then they are basically the same shape, right? Exact same shape, just different in different places. So I'm going to also say that AB is congruent to CD. Okay, that's pretty easy. Look forward to that on the test. It won't be on your homework, but look forward to that on the test, because I will probably put one like that on the test as extra credit. It's not that hard. Okay, so homework. And don't you love this chapter? So easy. Here's our chapter. Here's our homework. It's on page 225. Page 225. I want you to do the 1 through 7 all. And great job showing your work, you guys. I will talk to you tomorrow, okay? Hang in there.